Hey guys, welcome back. Alright, we are now back at my pitiful attempt at starts, and I want to talk about water nozzle sizes, in particular the diameter of the holes inside the nozzle, because I've been watering these with a watering can, a small watering can without any nozzles, and it was really annoying because there wasn't much control over it. Water kept pouring over the edge of here, and these grow lights were underneath, and I was worried that water was going to drip down into the fans. So I actually made these covers to prevent that. And I got to thinking about it a little bit more and decided that I needed to address the root cause of the problem, which was on the end of my watering can spout. These are the nozzles that I printed. The one on the far left was the very first one, and I quickly decided that the holes needed to be bigger and have fewer of them. What we're dealing with right now is just trying to find a good balance of how to break the surface tension. And the holes in that one are 1.5 millimeter. And I put a whole bunch of them in there. I'll show you how this functions. I'll show you how all of them function. We are going to get a little bit of leakage coming off the back of each one because I wanted to figure out which one worked best. I wanted to optimize it before I glued it on there. So just keep that in mind as we go through the test. We've got a flat over here that I've loaded up with dirt, and we'll run each nozzle over one pass, and I will show you how that works out. The snap, crackle, and pop mic is MIA, so I'll just do my best to speak louder so you can hear me. We're going to start with the 1.5 millimeter hole nozzle. Okay, now my thought process was that's too many holes and they're too small. So I changed to 5 holes at 3 millimeters. So that confirmed my suspicions that I was on the right track, but it seemed to be not good enough. So I went with a 2.5. Pretty nice. And then I said, can I make it any better with a 2.25? Very nice. That's good for seedlings, you know, in case you got loose seeds down there, it's not going to wash them away or dislodge them out of the dirt. And then I said, well, you know, why not try 2 millimeters? And just for kicks and giggles, here is what it looks like with none. So ultimately what I landed on, or what I liked, is the 2.25. Now, I printed these using a 0.3 millimeter nozzle. When you get down to holes this size, your nozzle size is going to make a difference. Like let's say you print the same STL of a 2 millimeter hole with a 0.8 millimeter nozzle and a 0.4 millimeter nozzle. Your hole for the 0.8 millimeter nozzle is going to be smaller than it is for the 0.4 millimeter nozzle. So just keep that in mind. If you're printing with a 0.4 millimeter nozzle, you might need to get the same results with I'm trying to figure out how this works without going backwards. Let's see. Bigger nozzle, smaller the hole. So
a few inches later.
Okay, if you weren't confused enough, I figured I'd give you a visual demonstration of what goes on. Let's pretend that we have two circles. These circles are going to represent the G code of the path that your nozzle is going to take. But over here we've got a 0.4 millimeter and a 0.8 millimeter nozzle. Now, as your 0.4 millimeter nozzle goes around and traces that G code, there's not going to be much squish out on either side of that line. But hypothetically, this is a 2 millimeter hole. When we have a 0.8 millimeter nozzle, I was trying to find a wider tip, but this will show you. As it lays it down, you're going to have more squish out on either side of it. And that squish out makes the inside diameter slightly smaller than the 0.4 millimeter diameter. So now I'm printing with a 0.6 millimeter nozzle. 0.4 is very common. So if you're printing with a 0.4 millimeter nozzle and want to get the exact same hole that I'm using, you're going to have to specify a slightly smaller hole in your model. And the smaller you get with your holes, the bigger this plays a factor. And layer height and material may also play a factor in dealing with the surface tension. And also, these were all printed on a satin bed like so. Alright guys, later.